looking at the special right triangles. So, often in trigonometry, there's going to be two types of triangles that you're going to be seeing. One is, let's just call it the 30, 60, 90 degree triangle ratio triangle. Basically, in this triangle, it has a 60 degree angle, a 30 degree angle, and a 90 degree angle. One of the sides is x, the other side is 2x, and the other side is x times the square root of 3. While the other special right triangle is two of the sides being the same, which is x, and x times the square root of 2. The two angles are 45 degrees, and the other angle is 45 degrees, while the last angle is a 90 degree angle. In past videos, I've explained how these values are often used in trigonometry. You can watch those videos. But today, we're just going to be solving these values, which are cos 30, which basically asks what is cos 30 degrees, sine 60 degrees, and tan 30 degrees, and what is cos 45 degrees, sine 45 degrees, and tan 45 degrees. So let's get solving them. So cosine means adjacent over hypotenuse. So if we look at the 30 degrees, if we look at 30 degrees right now, the side adjacent to it is this side, which is x times the square root of 3. So we write x times the square root of 3 over the hypotenuse. And the hypotenuse is just the longest side. So that's the hypotenuse. The hypotenuse would be 2x. Both of the x's cancel out. So we're just left with an answer known as the square root of 3 over 2. Next, let's solve sine 60 degrees. Sine 60 degrees, the side opposite to sine 60 is, let me fix that. The sine opposite to 60 degrees is x times the square root of 3, which is this side. So that is going to be the numerator, x times the square root of 3, over the hypotenuse, which I said before was 2x. It's 2x. So both of the x's cancel out, for the answer being left with the same answer as before, square root of 3 over 2. Now we see what tan 30 degrees is. So to solve this, the side opposite to 30 degrees is x. So this is the side that is opposite to it. So that will be x. And the side adjacent to it is, as I said before, is this side, which is x times the square root of 3. So we're left with an answer of 1 over the square root of 3. But I know oftentimes a lot of math teachers will ask it to be rationalized. So for this to be rationalized, we multiply this by the square root of 3 over the square root of 3. If you know radicals, you know that the square root of 3 times 3 is just 3. And then the square root of 3 times 1 is just the square root of 3. So the answer we're left with now is the square root of 3 over 3. And this is the answer in rationalized forms. I might be going over this in other videos, so make sure to watch them. Now let's move on to this triangle, which is the other special right triangle. The angles, as I said before, were 45 degrees, and 90 degrees. The first one, I think you can already project what the answers are going to be for this one. But cosine equals opposite over adjacent. So 45 degrees, you can choose whichever one you want. Let's just pick the bottom side. So adjacent should be this over x. So x over square root of 2. So 1 over square root of 2 times square root of 2 to make our unrationalized form. And then we're left with an answer known as the square root of 2 over 2. And I'm pretty sure you can guess what the next answer is. Sine 45, let's just use the same angle here. It's opposite. So then it would be x over x square root of 2. Just want to make sure to tell you guys that this is the hypotenuse. So then you would be left with the same answer, square root of 2 over 2. But then what comes interesting is on a unit circle, most of the times, as a past videos I've said that sine is the y value, x is the cosine value. So to find the tan value of other trigonometric functions, you just basically divide them. So if they're the same answer divided, then it would be 1. Or we could just see it over here. Opposite would be x. Adjacent would be x. X over x equals 1. They're the same thing. So this is basically the introduction to the special right triangles. Actually, you know what? Let me just show you how it is. Here, I'll just show you how we use it in trigonometry. Let's say we have this circle. I'm just going to quickly do one quadrant. Okay, so let's say that this is a 30-degree angle. Let me make it a little bit better. That's like 30. Okay, yeah, that's much better. Now we do one horizontal line down. And as you can see, that's basically the same triangle as this. So I hope this gives you a better understanding of how trigonometry is used in unit circles and how it can be used in more advanced mathematics, which I'll be covering in later videos. Thank you for listening, and make sure to like and subscribe.